Between 1952 to 1955, you could have purchased one of these Pilot Electric Manufacturing's Pilotone AA-903 mono integrated amplifiers for $70, or running through the inflation calculator about $840, $24. It had a power rating of not more than 1% THD at 10 watts, and if you lowered that down to 1 watt, the THD was supposedly not more than 0.1%. Its frequency response was listed at plus or minus 1 dB from 15 Hertz to 40 kilohertz. I was able to find the actual Allied catalog listing for this guy, and as you can see, there was also a matching FM only tuner or an AM FM tuner that you could purchase, and it looks like these originally had some sort of a cage over the top. Unfortunately, I do not have the cages. These do not belong to me, by the way. They belong to my good buddy Richard, and he was kind enough to lend them to me for this video. Plus, it makes it a lot more fun to test two monoblocks and listen to them as a stereo amplifier as well. So we'll do the standard tour, kind of see what's going on the outside, and then I'll turn it on its side and we can pop the bottom cover and we'll see what it looks like under there. And then of course there will be the data that I measured, as well as my listening tests and overall what I thought of using it. Here is a close-up view of the Pilotone AA903 Integrated Amplifier. Here is our on-off volume control. I'm going to come back to the equalizer in just a moment. We have our treble control here and bass control here. Now, there is no center detent position for these. I ran them pretty much the way you see them here. This equalizer knob is also your input selector, and there's inputs for auxiliary 2, 1, and radio. And then you have some different settings for the phono input. You can choose RI, AA, AES, NAB, LP, or FOR. The FOR stands for foreign. This is the rear of the AA903, and you can see we have taps for 4, 8, and 16 ohm speakers, and we do have a switched AC outlet over here. This is a view looking down from the top, and we have our two auxiliary inputs here and a tuner input here. Our phono input is here. We do have a phono level gain control, as you may, and it was set for maximum gain. I adjusted this hum balance such that the 60 Hertz hum bar that I saw using the QA403 analyzer was at its minimum. We have our tubes here, and in case you're wondering, we have a 5 Y3 GT here. We have two 12 AX7s here, a 64. We have our two 6V6 GTs and a 12 AU7 over here. Here is what the inside of the AA903 looks like once the bottom cover is removed, and you can see that a lot of the capacitors have been replaced with more modern capacitors. It looks like some of the original components are still here, but it did have several capacitors replaced. Right now we are looking at both of the Pilot amplifiers. I'm running them as monoblocks, and in case you're keeping score, the right channel in red is the Pilot amp with the knob that was not original that's on the volume on-off switch. And we've got it set up to put out 1 watt into 8 ohms, and the reason for that is there is a specification that the THD at 1 watt should be 0.1%. So we're not quite there with the left channel, and the right channel's 0.3%. So it's not too far off. SNRs are above 60 dB, and the gain was adjusted for 25 dB of gain for each of the amplifiers. Here we have the Pilotone amplifiers putting out about 5 watts into 8 ohms at 1 kilohertz, and this is just kind of our standard THD SNR plot. The volume controls have been set for 25 dB of gain, and you can see the THD went up a little bit from the 1 watt setting, so we're at what, 0.4% and maybe 0.6% THD we'll call it, and the SNRs are at least 66 dB. And in case you're wondering what the harmonics look like, we still have our even or second order harmonic higher than the odd or third order harmonics. Here is the frequency response with the Pilotones putting out about 5 watts into 8 ohms. And there is a specification that between 15 hertz to 40 kilohertz, the frequency response should be plus or minus 1 dB. Well, we are at 15 hertz over here, and here is 40 kilohertz. You can see at worst case we're down almost 4 dB. We'll call it 3.8 dB. So we would be failing at the high end of the band, and at the low end of the band we would be meeting our 1 dB requirement here at 15 hertz, or we're just a tad over 1 dB, but I'm not going to worry about that. If we go from 20 hertz to 20 kilohertz, so that would be from right here to right here, we would be down only 2.5 dB or maybe 1.8 dB. So either way, it's not going to meet the high-end specification of plus or minus 1 dB. But this thing is ancient, so I think it's doing pretty good all in all. When we connect the Pilotone amps to 4 ohm loads and look at the frequency range between 15 hertz to 40 kilohertz, we can see that it is different than it is when it was connected to 8 ohm loads. Now we're putting out about 5 watts into those 4 ohm loads, and none of the controls really have been adjusted other than the gain to try to get as much gain as we could, which was around 23 dB. It looks actually better for the left channel at the high end of the band. I mean, we're basically within plus or minus a dB for the left channel. The right channel fails that plus or minus 1 dB here at the low part of the band. Maybe at 20 hertz it's probably right at 1 dB, although you have this noise, and then at 20 kilohertz you're up 2 dB. So kind of like you have more gain with 4 ohm loads at the high end of the band, and with the 8 ohm loads you had less gain. But I think the response looked maybe more linear, flatter with the 8 ohm loads, but the frequency response overall looked better with the 4 ohm load. Here are plots showing the Pilotone amplifier's output impedance from 20 hertz to 20 kilohertz. There is no specification on the damping factor. However, if we do use the value at 1 kilohertz of about 1.4, we would come up with a damping factor of about 5.7. Keep in mind that these use output transformers to match to your speakers. Right now we're looking at the THD SNR response at 1 kilohertz with the Pilotone amps putting out about 10 watts into 8 ohms. And the reason for that 10 watts is there is a specification that at its maximum power of 10 watts into 8 ohms, it should be having a distortion reading of better than 1%. Well, we're about double that with the left channel and closer to it with the right channel. The SNRs are better than 63 dB, we'll say, and the THD plus noise is better than minus 33.64 dB, so that's not really good. Now, one thing to notice is the gain dropped a little bit. It was about 25 dB, and it seems like it's dropped a little bit. This performance is basically with the amplifier set for a gain of 24.5 dB, we'll just say. And in case you're wondering about the harmonics, here's our harmonic breakdown. You can see that the even harmonics, the second harmonics, are higher than the third or odd harmonics, which is typically what you would expect with tube amplifiers. Right now I've got the two Pilotone amps connected to 4 ohm loads through the 4 ohm load tap in the back. I've adjusted the gain, which I had to almost max out, and still could only get 23 dB to get the 5 watts into 4 ohms. You can see our distortion is about 0.31% for the left channel and about double that for the right channel. Now if you compare that to the 8 ohm load case, they're pretty much the same here, and the SNRs are not too different for what they were with the 8 ohm load case, and the THD plus noise is about the same. The main thing that went down was the gain. As I said, I could only get a little bit more than 23 dB of gain going into the 4 ohm loads. This plot shows the THD versus frequency at a couple different output power levels, and that would be into 8 ohms. -6 would be the equivalent of 9 watts into 8 ohms, and -16 would be about 1 watt into 8 ohms. If you keep in mind that the specification is that at 10 watts it should be better than 1% THD, we kind of see that we're just a bit above that here at the higher power level, which would be 9 watts actually. We're pretty close to 1 watt, and then as we decrease our output power levels, we kind of meet that for most of the band. A little bit at the low end of the band, the THD gets up to several percent here at the higher power levels, but overall for something that is this age, it is doing okay. In case you were wondering what the Pilotone mono amplifiers look like as far as their multitone response, well, here it is. There is no specification for it. It's kind of just here for grins and giggles, but what it shows is that there is a distortion-free range of between around 6 to 8 bits. So it's not very good, but it is what it is. It's kind of just there for reference. Here is a plot showing the system noise level of both of the Pilotone amplifiers. In this case, I have selected the auxiliary 1 input, which I've done for all the testing so far, and I have terminated those inputs into shorts, and you're just looking at the noise level of the system with the volume control set for about 25 dB of gain. Of course, the largest contributors to noise are the 60 hertz hum bar here, and the 120 hertz, and the 180 hertz, and so on. And then once you get down to the noise level itself, it's about -80 dBV down. Probably going to hear this when it's hooked up to the speakers, especially if I do hook them up to the Klipsch La Scala loudspeakers. This plot shows the Pilotone amplifier's intermodulation distortion, or IMD, and in this case the tones that are being used are 7 kilohertz and 50 hertz, and that's per the spec. It says that at full rated power, which we're not at, the IMD should be better than 2%. I haven't set up a spreadsheet to measure all these, but just off the bat, you're usually looking at sum and differences. So you're looking for 7 kilohertz plus or minus 50 kilohertz and that kind of thing. And we really don't see anything at plus or minus 50 kilohertz from 7 kilohertz. So I guess that's good. And these guys right here are all related to the 50 hertz from the initial 50 hertz signal, which is here. So I'm not sure how this would turn out if I created a spreadsheet for these two tones, but anyway, this kind of just shows what it looks like. Right now I've got a -46 dBV or 5 millivolt signal going into the phono input for the Pilotone integrated amplifiers, and that is my normal test signal for doing phono stages. Now we're getting about 41 dB of gain out. THDs are not looking horribly bad at all. I would say this one's pretty good. This is off a little bit. SNRs are not great, but for a phono stage that's okay. The interesting thing is we're only putting out about 36 milliwatts into 8 ohms, so I'm not really sure because this is like an integrated amp, and I've got the gain set pretty high. I could probably get a couple more dB out, so I'm going to go ahead and increase the volume controls, which should increase the gain, and see if we can get some more power. I'd like at least 4 or 5 watts out. So both of the volume controls are max. You can see we went up about 3 dB in the gain, but we still don't have that much power coming out. There is a position for phono loads, and it goes anywhere from 100K to 75K, and I've got it set at 75K. And there's also a phono level control, which I would imagine would be the gain, but we've got a lot of gain out of this stage, so I'm not sure I want to fiddle with that. I'm going to go ahead and increase the signal level going in and see if we start getting a lot of distortion before we get a reasonable power output. So right now I've got it putting out about 1.2 watts, I guess. But this guy has a rating of 1% THD at the full output power of 10 watts. So we're not too far off, but we've increased the signal level going into the phono stage by quite a bit. I'm not really sure what phono stages put out back then, but it looks like, you know, it's this phono stage itself is not looking real bad here as far as just, you know, overall what it looks like. If I continue to increase the input signal, then we are going to hit our at least 5 watts out. So it looks like you'd have to have a bit of a input signal for the phono to get this guy to give you any kind of volume out. Now, I will play with the phono gain on this. They call it phono level, and let's just look at the left channel. Let me get rid of the right channel here, and I'll just boost up the left channel and see what that looks like. We're at what, 42.2, and actually the gain is max, so the phono gain is at a max at this point. So I guess, you know, you just have to have a big phono signal going in. Maybe it required another preamp, because it's not going to do it with a typical 5 millivolt signal going in to the phono stage with this particular integrated amplifier. Now I'm going to go over to the frequency response area and see what some of these other settings for the phono stage, I believe it is. They have one for NAB, one for LP, one for AAS, and we'll see what difference in frequency response those controls make, if any. Right now we're looking at the frequency response of the phono input stage of both of the integrated amplifiers, I will call them, and the range that we're looking at is 20 hertz to 20 kilohertz. Keep in mind that I've got a rather large signal going in, as I did with the THD plot, so it's minus 26 dBV or so, and normally for testing phonographs I would have minus 46 dBV. So this level gives us pretty close to 5 watts out into 8 ohms. And right now I have the selector, they call it equalizer control, set for the RIAA position. And what I'm going to do is keep the right channel on the RIAA position and then move the left channel, and we'll see how those different equalizers affect things. So right now I'm going to move to the AES position. Looks maybe like it boosted the left channel up a little bit on the low end of the band. The next position is the AEB position, and it looks like the left channel is losing even more of its high end frequency response. This next equalizer position is LP, and it also looks like it killed the bass a little bit and also maybe killed the high end a little bit. Not sure what FOR stands for, but let's see what it does to the response here. And actually it looks like it smooths it out a bit. I mean, at the high end of the band it looks pretty good, and you know, it's got a lot of noise in it. Who knows what all that is caused by. But anyway, those are the equalizer positions of the Pilotone integrated amplifiers. Right now I have a 1 kilohertz sine wave going to the input, and this would be the auxiliary input of the Pilotone amp. Just one of them. We're just going to look at one amp. And that would be the purple trace here. The output, which would be across an 8 ohm load, would be the yellow trace, and you can see right away that there is a 180 degrees phase shift between the input and the output. So once you invert one of the signals, in this case I inverted the output, so it's 180 degrees out of phase, then this kind of can just actually show our phase delta less than 180 degrees, of course. And at 1 kilohertz, basically, there is no phase shift. If we go over to 10 kilohertz, you can see that we do have a phase shift between the input and the output. That's in addition to the 180 degrees that they're out of phase. And if we go over to 100 hertz, you can see that that increase in phase is about the same, maybe a little bit more at 100 hertz between the input and output, less the 180 degree phase shift. This plot shows the rise time of the input signal as well as the output signal in yellow. You can see the rise time of the input signal, and this would be at 1 kilohertz, is about 40 nanoseconds, and it's calculating the rise time of our output, and this is into 8 ohms, and we have about a this says 1.75 microseconds, and it was calculated at 1.68. So that's kind of the rise time of the output waveform. It does have some ringing attached to it. However, I just kind of wanted to show you how it compares to maybe some of the other amplifiers that I've tested. I should mention that the AA903 is about 12 inches by 7 inches by 9 inches and weighs in at 15 pounds. As you saw from the test data, both of these integrated amplifiers measured pretty much the same, and they fell short of their 69-year-old specifications. However, the THD, at least at max power for one of them, was close. The other was about double the 1% rating. And at 1 watt, they were both in the less than 0.5% THD, if I remember correctly. Now, the frequency response was lacking what it was spec'd out at. Even if I went from 20 hertz to 20 kilohertz, it still was not within the plus or minus 1 dB specification. Possibly playing with the bass and treble controls a little bit more may have helped me get a better response, but I tried it a little bit and it started giving me more of a smiley face kind of response when I started adjusting those controls. So they just kind of were set for mid-range. Now, as far as the phono input, that is something I would not use. I'm not really sure what you had to do for a phonograph back then, but it certainly required another preamplifier or a really strong phono stage to be able to get this to put out some decent power to drive loudspeakers. Obviously, the damping factor was not very good, but a lot of tube amps of the time haven't given me good damping factors. So sometimes damping factor is just kind of just a measurement and compare it to the spec. This didn't have any specification for it, but I just kind of like to look at it. So with all that being said, how did it sound? Well, I hooked it up to my Wilson Watt 3 Puppy 2 loudspeakers and let it warm up for a while. Now, I terminated both of the inputs, and for all of the testing, I used the auxiliary 1 input, and I just let it sit there for probably a good half hour, and then I listened to it for hum and hiss. Now, the volume control was set at about 3/4, so probably 22, 23 dB of gain. And the hum and hiss was much lower than what I expected. It wasn't really that loud or disturbing, and when you backed away a few feet, you didn't hear it. So that was a nice sign. And then I listened to a variety of music that I normally do, and I thought it sounded really good. I hooked it up to my Carver C1 preamplifier and used that to adjust the volume to the amplifiers, as well as I boosted the bass a little bit. And believe it or not, with all the measurements that I did for the frequency response, I thought it sounded really nice. In fact, if I didn't already have a pair of monoblock amplifiers, I might be considering these just for normal listening, as long as you don't want to put over, I would say, 6-7 watts out. Maybe you could go a little bit more than that, I suppose, but just for the normal listening I did, I got up to 82 dB SPLs with the Wilson, which was a pretty loud level, to be honest. If I were just reading and listening to music, it would be much lower than that. But if you had some people over and you wanted it for background music, 82 dB would be plenty good for that level. And I thought it sounded really good, to be totally honest. It's kind of surprised me. As I mentioned earlier, if I didn't already have a pair of Monoblock tube amps, I might be trying to talk to Richard into making me a deal on these, because they kind of look cool and they are a neat amplifier. As always, I'm looking forward to seeing your comments, and I try to respond to them all. A biggie is, if you haven't subscribed to the channel, please do so. And if you like the video, give it a thumbs up. So, once again, until next time, have a great day or night.